Line inclined to both planes. There are two cases over here. The two cases are formulated considering the angles made by the views on the HP and VP. Let us consider the angle true length makes with HP is equal to theta. The angle true length makes with VP is equal to phi. So the two cases are theta plus phi less than 90 degrees and theta plus phi is equal to 90 degrees. Let us discuss additional information which is considered in these cases. The length of the line for front view is A'(B1'). The length of the line for top view is AB2. Angle of true length with HP is theta. Angle of true length with VP is phi. The angle of front view with XY is alpha. Angle of top view with XY is beta. Here, alpha and beta are called as apparent angles. Now let us discuss the procedure for first case, theta plus phi less than 90 degrees. It consists of three steps. Step 1. Draw the XY line, say 100 mm. Keep a point A' above the reference line at a distance that is given below HP. From there, draw the front view true length with given inclination and mention that last end as B1'. Draw a horizontal line from A' and draw horizontal line PQ as the locus line of B' from the point B1'. Keep a point below the reference line at a distance that is given in front of the VP. From point A, draw a horizontal line. Next, project a line from B1' downwards so that it will intersect with the horizontal line drawn from point A. Name that intersection point as B1. This AB1 line gives the top view projected length. It's not final, still we need to give the inclination to this line. Step 2. From the point A, draw the top view true length with given inclination and mention that last end as B2. From there, draw horizontal line RS as locus line of B. Then project the line from B2 upwards until it touches the horizontal line of A' and name this end as B2'. This A'(B2' line gives the front view projected length. It is not final, still we need to give the inclination to this line. Step 3. By taking the compass, by fixing a length of AB1, draw a locus arc from point B1 until it touches the locus line of B and name it as point B. Join point A and point B. This is nothing but the original and final projection made on HP. Then taking the compass, fixing it at length of A'(B2', draw an arc from B2' until it touches the locus line of B' and name it as B'. Join point A' and point B'. This is nothing but the original and final projection made on VP. This is how we get the apparent views from the given true inclinations. The lines A', B' and AB are final projections drawn on the drawing sheet. Measure the angles they made with horizontal and they are called apparent angles alpha, beta. Here we can identify that the true inclinations are less than the apparent angles. Now let us discuss a problem on this case. Draw the projections of a 75 mm long line when it is 30 degrees inclined to HP and 40 degrees inclined to VP. Assume the end point A is 20 mm above HP and 30 mm in front of VP. Step 1. Let us draw an XY line, say 100 mm. Right above the XY line as VP and below the XY line as HP. Now keep a point A' with 20 mm distance from the reference line, that it is nothing but the distance above the HP, and draw a horizontal line from A'. Set the angle theta is equal to 30 degrees at point A dash and draw a line with length 75 mm as true length. Name the endpoint as B1 dash and through the point B1 dash draw a horizontal line as the locus line. Now keep point A below the reference line with 30 mm distance, which is nothing but the distance between VP and A. Then draw a horizontal line from point A. Now project a line downwards from point B1 dash until it touches the horizontal line drawn from point A. Name that intersection point as B1. This AB1 line gives the top view projected length. It is not final, still we need to give the inclination to this line. Step 2. Now we draw the true inclination the line makes with VP. Set the angle as phi is equal to 40 and draw a line with length 75 mm true length and name that n as B2. Here AB2 is the top view's true length. Now draw a horizontal line from B2 as the locus line. To get the front view, project the construction line upward from point B2 until it reaches the horizontal line drawn from point A dash above XY line and name this intersection point as B2 dash. This A dash B2 dash line gives the actual front view projected length. It's not final, still we need to give the inclination to this line. Step 3. Now we are merging step 1 and step 2. Now take the compass by fixing a length of AB1 and draw the locus arc from point B1 until it touches the locus line and name it as point B. Join point A and point B. This is nothing but the original and final top view projection made on HP. Repeat the same procedure for final front view also. Take the compass and fix it at a length of A dash B2 dash. Draw an arc from B2 dash until it touches the locus line and name this end as B dash. Join point A dash and point B dash. This is nothing but the original and final front view projection made on VP. This is how we get the apparent views from the given true inclinations. The lines A dash B dash and AB are the final projections drawn on the drawing sheet. Mark the given dimensions as given. Measure the apparent angles if necessary. The required orthographic projections have been made by using the above procedure. Line inclined to both planes. We know that there are two cases, theta plus phi less than 90 degrees and theta plus phi is equal to 90 degrees. We have already seen the procedure for the first case. Now let us see the procedure for the second case, theta plus phi is equal to 90 degrees. Some of the points before starting the problem. Here in this case, a line is contained by a profile plane. A profile plane can be drawn right side of the front view and the line is parallel to profile plane such that it is 60 degrees to the HP and 30 degrees to the VP. Both the top view and front view will be perpendicular to XY and there are less than true length. Both apparent angles will be 90 degrees. Now let us start a problem. A 100 mm long line AB has its end A at 10 mm above the HP and 70 mm in front of the VP. The line is inclined at 60 degrees to HP and 30 degrees to the VP. Draw its projections. Now let us draw the XY line, say 100 mm. Here from front and top view we are not able to get the true length. So first we are going to draw the profile plane view. For this special purpose, draw a x1y1 line which is perpendicular to the xy line to represent the side view. Now according to the problem, keep a point A double dash 10 mm above the HP and 70 mm in front of the VP. From that point, set an angle 60 degrees and draw a line with 100 mm. Keep the end point as B double dash. Then produce the line left side and select a particular position on HP. Draw a line vertically intersecting the two horizontal lines and name as B dash A dash. This is the front view. It is reduced in size due to its inclination. Draw a line downward with 45 degrees from intersection of two lines XY and x1, y1 lines. Now produce the construction lines downward from the point A double dash and B double dash until they touch the 45-degree line. From there, draw horizontal construction lines individually on HP. Extend the construction line down from the front view. These two lines intersect each other and identify the similar points. Name it as AB. This is our required top view. Keep the dimensions as much we need for our views. Hence, our orthographic views can be made by the following procedure.